Ever wonder about the sheer power of the sun and its impact on our daily lives? This celestial body, around 93 million miles away, is not just a source of light and warmth. It's a nuclear furnace, a colossal powerhouse that has been burning for about 4.5 billion years. The sun is composed primarily of hydrogen and helium, with hydrogen atoms fusing together in a process called nuclear fusion to produce helium. This fusion process releases vast amounts of energy, which we perceive as light and heat. Every second, the sun generates more energy than humanity has used in its entire history. But the sun's power isn't always benign. At times, it can be explosive. These explosions are known as solar flares. Solar flares are sudden eruptions of intense high-energy radiation from the sun's surface. They occur when magnetic energy that is built up in the solar atmosphere is suddenly released. This release of energy causes the sun's plasma to heat up to tens of millions of degrees, accelerating particles to near light speed and producing a burst of radiation across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. These solar flares are the largest explosive events in our solar system, emitting up to 1/6 of the total energy output of the sun each second. They're so powerful that, despite the vast distance between the sun and Earth, they can have significant effects on our planet. Now, you might have heard rumors about these solar flares and their potential to wreak havoc on our technology, particularly the internet. It sounds like something straight out of a sci-fi movie, doesn't it? But is there any truth to it? Could these powerful solar eruptions really pose a threat to our interconnected world? But what happens when these solar flares reach Earth, and could they really end the internet? Let's dive deeper into this fascinating topic in the next scene. Solar flares are not just amazing light shows in space, they carry a lot more than just spectacle. Let's start by defining what solar flares are. In essence, they're violent eruptions of energy that occur on the sun's surface. The sun, a gigantic ball of hot, glowing gases, is powered by nuclear fusion. This process creates an immense amount of energy, some of which gets stored in the sun's magnetic field. Occasionally, this energy gets released in the form of solar flares. Think of it like a colossal solar sneeze, if you will. A sneeze that can release as much energy as 1 billion megatons of TNT. That's equivalent to tens of millions of Hiroshima atomic bombs going off at the same time. Astonishing, isn't it? Now, these solar flares are composed of particles and electromagnetic radiation. The particles include protons and electrons, while the radiation comes in the form of X-rays and ultraviolet rays. When these flares are directed towards Earth, they cause what's known as a solar storm. But don't worry, these solar storms don't pose a direct threat to us humans on the ground. Our atmosphere does a fantastic job of shielding us from this harmful radiation. However, the story is a bit different when it comes to our technology. Before we get into that, let's discuss how these solar flares interact with Earth's magnetic field. Our planet has a protective magnetic field that extends into space called the magnetosphere. It acts like a giant shield, deflecting most of the sun's harmful radiation. When a solar storm hits, it disturbs this magnetosphere, causing a phenomena known as a geomagnetic storm. This is where things get interesting. These geomagnetic storms can induce electric currents in our power grids and telecommunications networks, potentially causing widespread disruption. To put this into perspective, imagine a city during a power outage. No lights, no internet, no refrigeration. Now imagine that happening on a global scale. That's the kind of disruption a major solar storm could potentially cause. But it's not all doom and gloom. Our technology has advanced to a point where we can predict these solar storms and take necessary precautions. Moreover, solar flares are not a daily occurrence, and major ones that could potentially disrupt our technology are even rarer. Understanding solar flares and their interaction with Earth's magnetic field is crucial in our technologically driven society. It helps us prepare for potential disruptions and mitigate their impact. Now that we understand what solar flares are, let's delve into their potential impact on our digital world. Our modern society heavily relies on technology, but what happens when a solar flare strikes? Let's dive into this. Picture this. You're sitting at home, scrolling through your favorite social media platform, or perhaps you're midway through a gripping online game, and suddenly the screen goes black. Your Wi-Fi's down, your phone's not working, and you're plunged into an unforeseen digital darkness. It sounds like a scene from a dystopian novel, but it could be a reality if a large enough solar flare hits Earth. Solar flares are like the sun's temper tantrums, throwing out copious amounts of energy and charged particles into space. When these reach Earth, they can wreak havoc on our technology. But how? Well, these charged particles can cause a surge of electrical currents in power lines, leading to widespread power outages. Remember the blackout in Quebec, Canada in 1989? That was due to a solar flare. Millions were left without power for up to 12 hours, and it was a pretty potent reminder of how dependent we are on electricity. It's not just our power grids that are vulnerable. Satellites orbiting Earth are also at risk. These satellites are crucial for a multitude of services we rely on daily, from weather forecasting to GPS navigation and yes, internet connectivity. Solar flares can damage these satellites, disrupt their functions, or in worst-case scenarios, knock them out entirely. Imagine trying to navigate to a new place without GPS or check the weather forecast for your weekend getaway, and you'll get a sense of how disruptive this could be. And remember, these satellites aren't easy or cheap to replace. A major solar flare could set us back years in terms of technological progress. But it doesn't stop there. Did you know that solar flares can also mess with radio communications? That's right. The charged particles from a flare can interfere with the ionosphere, the layer of the Earth's atmosphere that reflects radio waves. This can lead to the disruption of radio, television, and even mobile phone signals. In a world where we're used to instant communication, this could be more than just an inconvenience. It could impede emergency services, disrupt aviation and shipping, and generally throw a wrench in the smooth running of our society. So, we see that solar flares can cause some serious technological disruptions, but can they really end the internet? Keep watching as we delve deeper into this fascinating and slightly terrifying topic. Imagine a world without the internet. Scary thought, isn't it? But can solar flares turn this into a reality? Let's dive into the heart of the matter. The internet, as we know it, is a vast network of interconnected devices. It's a global web that weaves together our computers, smartphones, tablets, and a myriad of other devices, enabling us to communicate, work, and entertain ourselves. This network relies heavily on satellites orbiting Earth and undersea cables spanning the ocean floors. Now you might wonder, what do solar flares have to do with this? Well, solar flares are essentially massive explosions on the sun's surface that release incredible amounts of energy and charged particles into space. When these particles reach Earth, they can cause what's known as a geomagnetic storm. A geomagnetic storm is a temporary disturbance of the Earth's magnetosphere, caused by a solar windshock wave and/or cloud of magnetic field that interacts with the Earth's magnetic field. This interaction can cause disruptions in our planet's electromagnetic field, and lead to all sorts of technological disturbances, including disruptions in satellite operations and signal transmissions. So let's bring the internet back into the picture. Our reliance on satellites for data transmission means that a significant solar flare event could potentially disrupt internet services. This is because the charged particles that reach our planet can interfere with the functioning of these satellites. They can cause temporary glitches or even permanent damage, depending on the intensity of the solar flare and the resilience of the satellite's design. Undersea cables, which carry the bulk of our international data, are also not completely immune to the effects of solar flares. While they are less vulnerable than satellites due to their location deep under the ocean's surface, they are not entirely safe. Geomagnetic storms can induce electrical currents in these cables, potentially causing damage and disruptions in data transmission. Furthermore, the servers and data centers that power the internet are not invincible. A powerful geomagnetic storm could potentially cause issues with electrical grids, leading to power outages that could affect these vital components of the internet infrastructure. So when we talk about solar flares ending the internet, it's not a question of the internet disappearing entirely. Instead, it's about the potential for widespread and potentially prolonged disruptions that could significantly impact our ability to access and use the internet. This isn't just theoretical. In the past, solar flares have caused significant technological disruptions. The Carrington event of 1859, for instance, caused telegraph systems across Europe and North America to fail, with some telegraph operators even receiving electric shocks. Today, our technological infrastructure is far more advanced and interconnected, meaning the potential impacts of a similar event could be even more significant. But before you start panicking and stockpiling books and board games to prepare for an internetless world, it's important to remember that such extreme solar flare events are rare. Our sun is a relatively quiet star, and while solar flares do occur, the kind of event that could cause widespread technological disruption is not a common occurrence. However, this doesn't mean we should simply dismiss the threat. As our reliance on technology and the internet continues to grow, so too does our vulnerability to solar flares and other space weather events. It's a challenge that scientists, engineers, and policymakers are actively working to understand and mitigate. So, the threat is real, but is there anything we can do to protect ourselves and our digital world? Being at the mercy of the sun's tantrums sounds intimidating, but there are ways we can prepare and protect our technology. Now that we've understood the power of solar flares and their potential impact on our internet, let's venture into the realm of prevention and protection. First and foremost, early warning systems are our primary defense. Scientists are constantly monitoring the sun, tracking its activity to predict solar flares. This vigilance allows us to receive a heads-up, usually about 8 minutes before a flare reaches Earth. While 8 minutes may not sound like a lot, in the world of technology, it's enough time to take some protective measures, like switching to backup systems or going offline temporarily to avoid damage. But what about the technology itself? How can it be safeguarded? This is where shielding technology comes into play. Our tech devices can be fortified with certain materials that can withstand the electromagnetic onslaught. For instance, satellites, which are particularly vulnerable to solar flares, are often equipped with protective shields made of aluminum or copper. These shields can effectively block out damaging solar radiation, ensuring the longevity of our space-based technology. Moreover, engineers and scientists are also exploring the potential of hardening electronic systems. This involves designing devices and infrastructure in such a way that they are inherently resistant to the effects of solar flares. This could mean using components that are not easily affected by electromagnetic radiation or designing systems to automatically switch off in the event of a solar flare. Prevention is always better than cure, so it's crucial that we continue to invest in and develop these protective measures. After all, our reliance on technology is only set to increase in the future, and with it, our vulnerability to solar flares. So, while solar flares pose a threat to our digital world, we're not completely helpless. With the right preparation and protective measures, we can ensure that our technological world continues to function, even when the sun throws its tantrums. So, can solar flares really end the internet? The answer is a bit more complicated than a simple yes or no. We've journeyed together through the power of the sun, the nature of solar flares, and their potential impact on our technology. We've unraveled how these fiery phenomena could pose a threat to our beloved internet. Solar flares are powerful, no doubt. They can disrupt our technology and have a profound effect on our modern way of life. But it's not all doom and gloom. We've also explored how we can mitigate these threats through technological advances and preparedness. The internet, like many other aspects of our world, is not completely immune to the tantrums of the sun, but with understanding, vigilance, and the right measures in place, we can weather the storm. While the sun is a formidable force, with understanding and preparation, we can ensure that its tantrums don't leave us in the dark. Until next time, stay curious, stay informed, and keep looking up.